When we talked about the basic timing of two devices communicating on the SPI bus, we have mentioned that the sampling and the driving happens on different active edges of the clock, of this SPI clock. For example, we mentioned that the sampling happens on the positive edge in here and the positive edge, while the driving is actually happening on the negative edge. The SPI protocol allows us to change this behavior a little bit, and it allows us to change this behavior using a couple of things, which are the clock polarity and the clock phase. Okay, so let's discuss what these are. So the clock polarity is pretty straightforward. So it can either take a value of 0 or value of 1. And what this value tells me is what is the actual value of the SPI clock in idle. So in this particular example in here, we have said that the clock is actually set to 0 when it's idle. So that means the C pole, or C polarity, or the clock polarity is actually 0. So this is actually the one we care about in here. At least this is the one that is set up in this particular diagram. The clock phase, or CFPHA, is a little bit different in here. You can also set it up to 0 and 1, but its meaning is a little bit harder to define. But the simplest way to look at it is the following. So if it is 0, it means that the very first bit you're driving does not need a clock edge. So let's take a look in this here and we'll see. So we said that at the slave select in here, the clock was at 0, and then you moved in here and then you started the clock and you actually driven the first bit of the master in here. So in here, what we're saying is the clock was at 0 and the clock started at the very beginning, and the first driving happened without actually needing any edge. And in this particular situation, the phase is actually at 0. If the phase was at 1, what we would need is at the very first edge, the clock should actually go to the top, and of course everything flips at that point. So what I'm doing is I'm effectively changing the phase of this particular clock. So in here, what we see is actually the value 0 and 0. And of course, because we have these two parameters in here and each one of them can take a couple of values, that means we have in total exactly four modes. And the modes we discussed and we actually explored in the timing diagram is actually what we call mode 0. And this is actually when the polarity is 0 and the phase is actually 0. So let's see what the other modes look like. So the mode 1 actually tells me the polarity is 0. That means the S clock is actually 0 when it's idle. That's what the polarity tells me. And just quickly, you can see that the polarity in here is 1. The polarity in here is 1. That means the clock in here is 1. The clock in here is 1 when it's idle. So the phase, this one, we explained it in such a way that when the clock starts, basically the very first clock, the first driving happens without any active edge. So if it was at 0, it stays at 0. In here, it tells me that the phase is 1, the clock was at 1, or was at 0, and then at the very first one, you want to drive on an edge. So what happens is now you need to raise it, or the master would raise it in here. So if you pay attention to mode 0 and mode 1, you'll see that they're almost exactly the same. They're just phase shifted. And this is why we call the second one is actually a phase shift. So it's just phase shift, just does a phase shift. So in here again, what we have is the clock again is at 1. And the first one, because the phase is at 0, I'm just going to do the sampling without an edge. So I'm going to continue at 1. And the same goes in here. We have basically it was at 1. And then because the phase is at 1, I need to actually have an edge. So these particular modes of operations in here that you see depends like which one should you use, you might be asking. And the answer is depending on the peripheral you're communicating with. So SPI allows you to use all of them. So what happens is you're going to have to figure out what the peripheral or the slave you're trying to communicate with, which mode it's expecting, and you just set your master controller to actually do this. And the mode of operation is usually changeable using a driver and the application. One more comment in here is that I want you to know that mode 0 is the complete opposite of mode 2. Okay, and basically the complete reciprocal, like as if you put this one here through a NOT gate. That's what you have. And the same goes between mode 1 and mode 3. So here what we have is driving happened on the negative edge, and in here driving happened on the positive edge. Of course, driving happens on the positive edge in here, and driving happens on the negative edge. Sampling will be happening on the other edge.